Mathematics at Init College, a YouTube channel for high school mathematics education. Mathematics 1C and Mathematics 3C, Swedish high school education system. Functions. Hi, this is Babak. In this video I'm going to solve the following problem for you. Let me read the problem for you first. Let f be a function such that for every real number x, which is not equal to minus 1, I have f of 1 minus 2x over x plus 1 equals to 3x. Determine the rule and domain of this function. That's a good idea if you can pause the video at this point and try to solve the problem yourself first. The answer that you will get would be f of x equals to 3 minus 3x over x plus 2, and the domain of function df would be the set of all x's in R, the set of real numbers, such that x is not equal to minus 2. Okay, now let us start solving the problem. If you have watched the previous video, you have enough experience what to do with these problems. So you see that this is a little bit of unusual of defining a function. Usually we use the input as x, but here we have a combination of x which is given for the input of my function. So and then I want to find what happens if I put just simply x in it. So in principle I want to find the rule of my function. From the previous video you learned that a good trick for this is to say introduce a new variable. So let 1 minus 2x over x plus 1 be equal to, say for example, capital X. Then you need to rewrite this expression in terms of your new variable. Of course, this is not a big deal. Instead of this, I just simply put capital X, but I need to get rid of this little x here. To do that, I have to solve this equation and to try to find little x in terms of the capital X. Okay, what can I do? I can multiply, so let me write it from here, 1 minus 2x over x plus 1 is equal to capital X. I multiply both sides by x plus 1. The left hand side becomes 1 minus 2x. The right hand side becomes capital X times x plus 1. Yes? And then I continue. So this becomes 1 minus 2x. On the right hand side I multiply this in. So it becomes capital X multiplied by small x plus capital X times 1, which is just simply capital X. Don't get confused, you are thinking about finding x. So this has a small x in it, this term has a small x in it, so I move them to the same side, okay? So I will move minus 2x to the right and this capital X to the left. So what I get, it becomes 1 minus capital X equals to, I have capital X times x. Then I move this minus 2x to the right, it becomes positive 2x. So then it becomes positive 2x. In the next step, I write 1 minus x as it is on the left, but here I can pull x out, little x out, yes? So what is left for me is that I will have x plus 2 multiplied by little x. What was my goal? My goal was to find x in terms of capital X. So it means that I have to divide both sides by capital X plus 2. So the left hand side becomes 1 minus x divided by x plus 2. The right hand side is just simply x. So that is what I was looking for. I wanted to write little x in terms of capital X. Now you go to your function here, to this equation. Instead of this expression you can write capital X, and instead of this part little x you can replace this expression in. So what you get is this. You will get f of capital X is equal to 3 times little x. But little x is expressed in terms of capital X as 1 minus x divided by x plus 2. So this can be, this 3 here can be multiplied in the numerator. So this tells me that f of any input x, call it capital X, it doesn't matter, it becomes 3 minus 3 capital X divided by x plus 2. Okay? But then what does this mean? It means that f acting on an input which we call it capital X follows this rule, yes? So now it doesn't matter, of course you can leave it like this is the rule of the function, but because it is common to express the input with little x, so I would say that okay, it's better to write f of little x is equal to 3 minus 3 little x divided by x plus 2. Okay, so don't think that I am taking x away and I'm putting x inside because x and x are equal. You see, they are not. What I'm trying to say is that this tells me how f acts on an input called capital X. If the function applies on this capital X in this form, it is clear that it will apply on any other variable, including the little x, in the same way. So this is finally the answer that I get for the rule of this function. Okay? Another part of this question is that what is the domain of this function? So the domain of this function is the set of all possible values that you can choose for your input x. Okay? So you see that you can choose whatever you like for x except one particular number. You cannot choose x equal to minus 2, because if you choose x equal to minus 2, what happens in the denominator? The denominator becomes 0, and you know that division by 0 is forbidden. So this is the only value, minus 2 is the only value that you cannot choose for x. So this means that the domain of my function is the set of all numbers, the set of all x in the real number, this means belongs to, but not exactly all of them, such that there is one restriction, and that is that x shouldn't be equal to minus 2. So that also gives me the domain of the function. Okay, below this video I will put the link to the PDF file of the solution to this problem. I hope that this video was useful for you. Until the next video, be safe and goodbye.